All right, we're live. Okay, so just a quick refresher of what we looked at yesterday, and then we'll get into the half-cell cell stoichiometry calculations here. So the first part we looked at yesterday was this lovely little formula, Q equals IT. Q is talking about the coulombs, right? This is for the coulombs, which is really talking about the charge of something, like how much charge did it take. T is talking about the time. In order to use time in this formula, time has to be in seconds, and I is talking about amps. Amps, the unit for amps is either A, or it can be coulombs per second, kind of depending on how you want to look at it. Why don't they use C for the letter A for coulombs or for amps? C is constant for speed of light. Is that right? Yeah. So it would have already been a letter that was used, and so they had to decide on something else. Okay, so then we take that Coulomb formula. We can just use that to figure out charge. Using that formula, I can also figure out the number of moles that would be required to run a circuit or a half cell for a certain amount of time. I was just saying. Talking about, so you can figure out the mole of electrons, right? I can use this to figure out the number of moles of electrons by substituting Q with the current and time over Faraday's constant, which is 9.65 times 10 to the 4, like moles per something. That's in your data booklet if you ever forget it. All right. So most of the questions I got you to look at yesterday, you were either just figuring out charge or you were figuring out moles of electrons or figuring out moles just based off of math. Just kind of getting you used to the formula so you could go look at the calculations from today. So half cell calculations, fruit fly. Coming with my eyeball. Okay, so first thing you need to do is write out the balanced half cell reaction. Most of these are very simple reactions, right? Like you're taking molten sodium chloride and you want to figure out how much sodium you would be able to produce. And so you take the Na positive plus an electron is producing Na solid, right? You're only using half reactions here. You have to make sure those are balanced. Once you are doing that, make sure that everything is in the appropriate units. The first thing you should do, same thing with any sort of stoichiometry, is go figure out the number of moles. You could either figure out the number of moles of electrons or the number of moles of something that is going to be reacted or produced, depending on what it is, right? So figuring out moles, I might be using Ne equals IT over F. Or to figure out moles, I might just be using N equals M over M. Just depends on what information you're given in the question. So that's the first thing you would need to do. The first thing after you have written your half reaction. The third thing you need to do is calculate the moles of the other substance that you're talking about. So you have to use your molar ratio. And so that comes back from stoichiometry in Chem 20, which you need to take that and times by where you're going to, divide by where you're coming from of those coefficients. And hopefully everybody kind of remembers what that looks like, but we'll look at that here in a second. And then the last one is just to kind of calculate whatever you're looking for. Are you looking for how long it would take to plate 20 grams of copper? Or are you looking at how much copper would be produced after 20 minutes at 40 amps, right? We can figure out all of that information. We just need to make sure we use it appropriately. All right, so here is an example. So what mass of copper will be deposited at the cathode of a copper electrorefining cell if it's operated for 12 amps for 40 minutes? And so essentially what's happening here is they have some sort of copper ore, right? Most metals don't exist by themselves. They're ores, and so we have to refine them. And so they're adding electricity to this impure copper ore, and what's happening, it would go into solution, and then once it's in the solution, it will attach on at the cathode as a purified form. So what mass of copper deposited at the cathode will be produced? So I'm going to be producing a copper solid, which means it should be starting with what? Copper aqueous, right? I'd be starting with copper 2 plus aqueous plus 2 electrons. Most of these half reactions you should be able to produce yourself without looking at your data table, but they're on there if you need them. From there, then, so they're asking me what mass. So they're asking me what mass is going to be here. Now, right now, I can't figure out mass because I don't know moles. I don't know anything else about that. So I'm going to have to come figure this out based off the information that they give me. And so I can take all of this information. So they're telling me that it's 12 amps for 40 minutes. And where would I put that under? You know, when we're doing Stioch, we always like to take the information and put it underneath the compound or element that it's referring to. Where would I put this information under? Cu2+, is that copper? When we're talking about like current and electricity, we're talking about what? The movement of electrons. So all of this information is going to go help me figure out the number of moles of electrons that are going to be used in this reaction. So really, I'm going to be looking for Ne equals IT over F. So I'm going to go find out the moles of electrons that were used during this 40 minutes at 12 amps. And so I is amps, so I'll put that information in for amps, so 12 amps. Again, if you use amps or coulomb per second, it shouldn't matter. 40 minutes, what do I have to do to that 40 minutes? Times it by 60 to get it to seconds, so this would be 2,400 seconds over Faraday's constant, which is 9.65 times 10 to the 4. Make sure when you're putting this on your calculator, like you put brackets around the numerator and the denominator. Otherwise, your calculator might just go through it in the order, a different order than you want it to. And so the number of moles of electrons that would be used during the running of this cell is 0.298 blah, blah, blah. And so that's where most people, we got to that yesterday. Everyone's like, okay, now I have the moles, but we didn't continue from there. And so all we need to do is continue with our stoichiometric process here. So I can use the number of moles of electrons to figure out the number of moles of copper that would be produced by just using my molar ratio. So I times by where I'm going to, so I'm going to times by what? Times by where I'm going to, the coefficient here is 1, so times by 1. Divide by where I'm coming from. I came from where? Electrons. And the coefficient of electrons is 2. So I would times that by 1 over 2. So times by 1 over, that's not the right button, 1 over 2. And that tells me the number of moles here is 0.149. And again, make sure you keep that trailing decimal in your calculator, because if you round that and it's a numerical response answer, and I need the answer to be 9.48 and you got 9.50, that's wrong on the diploma. Right? So make sure you keep that trailing decimal. So now that I know the number of moles of copper that reacts, what do I need to, or how do I figure out the mass? Pardon me? My molar mass, right. So I can go N equals M over M. I need to find the mass. I know the number of moles, I just figured that out. It's 0.149, and that would continue. I'm looking for the mass over the molar mass of copper. That's just one copper, so 63.55. So I'd cross multiply, and the mass of copper that's being produced is 9.48 grams. 9.48 grams. What formula? This? Where did I get that from? Yesterday? Q over F. Yeah, that helps me figure out the moles of electrons. We did that yesterday. Good talk. It works mathematically if you want me to show you the units after. No? Okay. Let's say I didn't offer. Alright, one more. So silver is deposited onto objects in a silver electroplating cell. If 0.175 grams of silver is to be deposited from a silver cyanide solution in 10 minutes, predict the current that would be required. So they're telling me that I'm depositing silver, so the first thing I need to do is go write out that half reaction. So I'm going to be producing silver solid, which means I started off with silver aqueous. Sorry, just let me write this down. Pardon me, what's your question? Because I'm depositing silver. Anytime I'm depositing something, it's usually, yeah, it's going to be solid. And when you electroplate something, right, like think about like chrome, or like if I electroplate something with silver, I'm essentially plating it in silver. Okay, and so they tell me that I'm just going to deposit 0.175 grams of silver. So the mass here is 0.175 grams. It's going to be deposited from the silver cyanide solution. Really what I'm taking from that is I started off with aqueous silver. In a time of 10 minutes, so time is equal to 10 minutes. That goes under the electrons, because that's just telling me like how long the cell ran for. We always put that with respect to the electrons. I will change it once I put it into the formula. And the last thing is looking for the current required. So what's the amp? Sorry, that's not the correct. It's I. I'm looking for I. So if I need to go figure out I, where am I going to go find moles, right? So once I've written my half reaction, I put everything where it needs to go, I need to go figure out moles. Can I find moles of silver aqueous? No, there's nothing even written underneath there. Can I find the moles of electrons? Why not? Pardon me? I don't have enough, right? If I'm going to go use this formula, Ne equals IT over F, I already have an unknown I, so I can't have also unknown moles of electrons. So that means I can go figure out the moles of silver. So N equals the mass over the molar mass. I need to go figure out how many moles of silver are in 0.175 grams. The molar mass, well, there's just one silver ion there, so one silver solid, so 107.87 grams per mole is the molar mass of silver. So I would divide those two, and the number of moles in that is 0.00162 moles. Someone remind me to say, remember this after. Good talk. Thank you. Just tell me to remember this after, and I'll remember what I have to remember. Okay? Once I figured out moles, and again, so most of the stuff that you did yesterday is you just figured out this portion right here. What you're going to have to go do is figure out what half reaction you're going to use, and then use your molar ratio. And so I need to take this to figure out the number of moles of electrons that would react. I'm going to times by where I'm going to, so I'm going to the number of moles of electrons, divide by where I'm coming from, which is silver. Yeah. Just remind me. That's all I'm asking, is to remind me. What's that? 1 over 1? How did I get that? Okay, so to get that, sorry. So times, or what did you guys say? I don't remember what Mr. Shelley's class said. Want versus have, right? I want to go figure out how many electrons there are, so want versus have. I have 1 mole, so that's 1 over 1. Or times where we're going to divide by where you're coming from, whichever works for you. And so then that tells me the number of moles of electrons, which is apparently the same as the number of moles of silver that are reacting in this cell, so 0.016, sorry, I forgot a 0, 2. So I'm trying to find the current in 10 minutes, which would be 600 seconds. 600 seconds over Faraday's constant, so 9.65 times 10 to the 4. And so I would cross multiply there, and then divide by 600. So cross multiply, divide, leaving me with the current is equivalent to 0.261 amps. 261 amps. Let me check my mathematics. And divide that by 600, 0.261, okay. And sig digs, obviously, you need to remember. Okay, so here's the thing to remember. And I'm not sure that this happens a lot, but if for some reason alright, so let's say for some reason I said how many moles are in 7 grams of chlorine gas. Make sure that when you're figuring out molar mass, you're only taking the tiny numbers, not the coefficients. Some people were doing that like on their, I think it was the thermochemistry test, right? If they're figuring out molar mass, they're also taking the numbers out front. Let's say there was a 4 in here, and they would like say there's 8. Well, you only use subscripted numbers when you're figuring out molar mass. Well, you're taking the coefficients into account when you do your molar ratio. So otherwise, it's redundant and you're not taking it into account at all if you times it. There is some old diploma questions on here. I'll just go through it just for the sake of looking at a few more examples. So, the reduction half reaction for a Hall-Héroult electrolytic cell. They talk about that a lot on the diploma. They always talk about this I can't even pronounce it, cell. You don't need to know what it is. You just need to know how to solve the question. So aluminum, adding 3 electrons to it, producing aluminum solid. So a current of 10 amps is applied for 5 hours. Then the amount of electrons being transferred. Now, is this really a half-cell question? Do I need to write out my balanced reaction? Like, does this actually tell me anything here? Why not? Right, I have amps and hours, and they're just asking me for the moles of electrons. So really, I would just be using this to solve the question. Them giving me the half reaction is almost a distractor, right? If they would ask me for the mass, well, then I would have to go find the moles here, times by my molar ratio, and I could go find the mass of aluminum, but that's not what they're asking me. I don't need to use it at all. They're kind of throwing it in there as a distractor. The only thing I would need to do is plug my numbers into here, and I'd get that answer. Is if you're finding mass, or like you got to go find amps, and they give you a mass. Yeah. All right, so here is an example where it would matter. So a Hall-Héroult electrolytic cell is used to produce molten aluminum from molten aluminum oxide, as represented by the following reaction. In the Hall-Héroult electrolytic cell, the time required for the cell to operate at 5.5 times 10 to the 3 amps to produce 10 kilograms of aluminum is what? Now, they give me this balanced reaction, but anytime I'm dealing with, like, amps and trying to figure out what mass or what time there would be, I need to use the half reaction. And so I would actually be using that half reaction they gave me before. Produces aluminum solid. And so they're telling me we're going to go produce 20 kilograms. So N is equal to 20,000 grams over aluminum, which I believe is 26.98, yeah. 26.98. We'll figure out the moles here. So 2,000 divided by 26.98 gives me the number of moles is 741. And people always be like, well, that's a really big number of moles. Well, yeah, but they just produced 20 kilograms of aluminum. You're going to have a lot of moles in that amount. So then I would take my number of moles and I would multiply it to where? Would I be going to the electrons or would I be going to the aluminum? Electrons. I need to go figure out how much time it would take for all those electrons to transfer over. So I times this by 3 divided by 1. And so times that by 3. So then if I'm going to go into this formula, Ne equals IT over F, the number of electrons is 2,223, blah, 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 equals the amps, 5.55 times 10 to the 3. I'm trying to figure out the time over Faraday's constant, so 9.65 times 10 to the 4. So cross multiply, so times that by 9.65 times 10 to the 4, and divide. So divide that by 5.55 times 10 to the 3. And that gives me a time of 38667. So is that the answer I would put there? Why? Right, this wants it in hours, so I gotta go divide that by 60. That gets me to what? Minutes. Divide that by 60 again, that gets me to hours. And so this would be 10.7 hours. I did already remember it. That was this chlorine thing that I talked about, just talking about molar mass. Make sure you do subscripted numbers for molar mass, not coefficients. Okay, so that's all of that. Most of them you've already started, so you should just have to write out the half reactions, molar ratio, and then finish the question. So you should be able to finish up question, homework, number 14. Tomorrow we'll do the review and start going through the review package.